let's review what we did last class, which was manually fit a line to some data. So remember how this works. We're going to build a scatter plot. So what do we have here? We have the number of hours studied for a math exam, and then the grade that we got in percents, right? Somebody studied for 2 hours, they got a 77%. Somebody else studied for 5 hours, got a 92%. So we have to put this on our scatter plot. Hopefully you got a chance to do this. Now, we didn't put any units on here, so we have to figure out units. I look at my lowest value and my highest value for my x's, my hours, 0 through 5. So we can go by ones. You might be able to skip a line, make it maybe slightly better or easier to read. But anyway, these are our hours. And then the grade. And the grade, there we go. I went by 10. Now if you went by something else, that's okay too. But I went by 10. So I put my graph on here. It's always a good idea to label your axes. So these are the hours studied, and this is the grade in percent that you got. So let's see, for 2 hours, and we do our best when it's not exactly on a line there, 77. For 5 hours, oops, that's in the wrong spot. Oops. 2 hours was a 77. 5 hours was a 92. That's all I'm reaching it or not. 1 was a 70. 0 was a 63. 4 was a 90. Another 2 that one got close but slightly lower than the other person, and 3 was an 84. So not the best looking drawing here, but it's something like that. Looks like I missed something. Did I miss something? Maybe not. Okay, so that's the scatter plot. And then you have to decide, do I see any correlation? Do we see any correlation? Yeah, what kind? Positive. Positive, and how do we know it's a positive correlation? It's going up. So when you figure the line of fit there, it has a positive slope, positive correlation, it's increasing. Now to manually fit the line, I'll use a different color here. We say, gee, what line could I put in between these points? And you make your best guess. You're like, I'm not sure. And it's hard for me to do in my little slide. That's totally this. All right, let's try again. I'm having a little trouble with my slate today. Something like this, right? You put in a line. Your best guess. So my line might be different from Kiara's line, right? It might be different from Olivia's line. It might be different, but it's what I got. Now, how do I find the equation of the line I just drew?
You need the slope.
Well, how do I get the slope?
You put 2 points on the line.
I need 2 points on the line. So am I looking at this column here and saying, gee, I think I'll pick 170 and 592. Is that how I'm picking my 2 points? No, no, no. Because maybe they're on my line, maybe they're not. I'm just looking red. Oh, here's one. This one looks like 6/100. I know what I'm going to pick. I'm going to pick this one. And it looks like 0.65-ish. I'm going to pick those 2 points. I could have picked any 2 points I wanted to as long as it's on the line. Now, are these our data points? No. I told in my last class saying, no, it's 0.63. I'm like, no, it's not. My line is on 0.65. The data point was 0.63. I'm not looking at data points now. Looking at my line. Is that clear? Because I know that's a little confusing for some people. Right? Don't just pick 2 points from here. Okay. Now, once I have my 2 points, find the slope, right? Slope formula is y2 minus y1 over x2 minus x1. So 100 minus 65. 35? 6 minus 0 is 6. Okay. And then what? What? Now I need an equation of a line. I want y equals mx plus b when I'm done. What do I do? I've got 2 choices here. Simplify this. Can I simplify this? I could make it a decimal. I'm only allowing it to be a decimal because we're doing regression. So wait a second. Let me just clear out my calculator. There's a lot going on here. If you haven't cleared out, you might want to. All right. If I make it a decimal, I might do that only because we're dealing with linear regression, and it'll make maybe slightly more sense when I'm doing it in a moment. But it's approximately 5.8. What's the equation of my line? What is it? I choose one of the points, yeah. form? You have a what and a what? Yeah, point slope. You have a point, you have a slope, point slope. Great. So yes, that is one way to do this. Now, I'm not going to though. Why am I not going to? I very carefully picked my point. I very carefully said, wait a second, why don't I pick a y-intercept? Isn't this a y-intercept? How do I know? The x is 0, right? Isn't it on the y-axis? Why is that a good thing to do if we can do it? Makes life easier, because in y equals mx plus b, what's b? Y-intercept. So what's my b for this line? 65. What's my equation? Y equals 5.8x plus 65. If you know m and you know b, y equals mx plus b. So that's, if you want a hint on how to make this your life easier, if you can pick a y-intercept, you can't always do it. And we'll see another example later when we can't. Like for example, if you have a line that kind of went like this, I can't see what my y-intercept is. Then you do exactly what Melena said to do. You pick 2 points. How does this work? Y minus y1. Y minus 65 equals m 5.8 times x minus 0. Or use this point, either one, and work it out. Yes, sir?
When you think the y-intercept, does it have to be one of the points?
It has to be one of the points on my line. It is not necessarily going to be one of the points they give you.
No, I mean the 2 points that you found.
You do not have to pick a y-intercept, no. But I picked it just because it made life easier. Plus, even finding slope, I'm subtracting 0. Anything that's going to reduce my chance of making a mistake, I'm going to try and do. You didn't have to. I could have picked like these 2 points. I could have. And then just use slope intercept, or point slope. Yeah.
So how come you can't use like 600? I mean 600 as the y-intercept? Why can't you use that?
Because it's not a y-intercept. Right? How do I know something's a y-intercept? It lives on the y-axis. How do I know something lives on the y-axis? What's its 0 value? Or its x value? 0. So if you have an x value of 0, it becomes easy. If you can't get it because the data doesn't allow it, that's okay too. You use point slope. So it's just something to look for first. So I got that pretty easily. Now, did anybody else get an equation? Anybody else get an equation for this? Yeah, what'd you get?
Y equals 7x plus 65.
7x plus 65. So who's right? You or me? Yes. Yeah, we're both right. We're both right. She drew her line slightly differently. That's okay. So what is the problem with the manual method of finding a line of fit? What's the problem with it?
Because everybody makes different.
Yeah, we're all going to choose slightly different lines. I like that we're close. You know, that's a good sign. But that's not what we want to do. So what I want to do is I want to go over how our calculator can help me. Actually, I forgot to do this. So, do you have a helper anywhere? Anybody want to help me tap this out? Thank you. You can put it in. Thank you. So, Uria's passing out calculator steps, but they're complicated when you first look at them. I think they're hard to read unless you've actually done this. So, while he's giving this out, let's kind of review how to do this. Does everybody have a calculator? So, let's use the calculator now because there really is, mathematically, we can figure out the best line of fit here. And you know, this might be fun to look at. Where is that? I got it. Yes, here's something. Yeah. Here's the formula if you want the best line of fit. So what you do is to find the slope is you take your number of points and you multiply times the sum of your xy's, the product of them. Subtract the sum of the x's times the sum of the y's, there's your numerator. Divide by n, number of points you have, times the sum of all your x's squared, the sum of those, minus sum your x's and then square that value. That gives you slope. If you want b, you take the sum of all your y's, minus the m you just calculated up here, times the sum of the x's, and just divide by the number of points you have. Here's m, there's b, y equals mx plus b. Done. And R, we're going to look at what R is. R is a really cool thing too. And you just use this little simple calculation. And you got it! So simple. And we're all going to get the same value. Isn't that great? But I got bad news for you on roots. I got very bad news for you. actually using that cool thing. It's out of scope of the course. You have to take a real statistics course if you want to do that.
Do what?
Use this formula. Yeah.
But,
But yeah, I know, but we have some happy news. You have a happy, look, everybody's got their happy face on now. Yeah, we are going to use the calculator to do it. Come on, I had to do that to you guys. You know, I had to. So let's use the calculator. Everybody is doing this with me. Second plus second one, two. If you haven't done it already, just in case the person before you didn't do that. What we're going to do is we're going to, in our table, in lists, put in our x values and put in our y values. Remember L1 and L2? Yes. So in L1, all our x values go, and in L2, all our y values go. Who remembers how to get there? Yeah, how do you get there, Uriah? Yeah. Edit. That edit. Okay, so is everybody looking at the lists? Yeah. All right, so in L1, what am I putting in? 3, 5, 1. Right, so look in your paper. Just type in all the x's, the hours. 2, 5, 1. You're going to be faster than me. It took me a long time at the row. What is in here? Okay, there's one. And then let's do this one. These are the weak scores. Everybody's doing it. Everybody should be doing it. Wow, that's good. Everybody's doing it. I don't hear enough clicking. I don't think everybody's doing it.
Okay, do we put the y values in this?
In L2, right? The y values go in L2. Check your data, make sure it's in right. Might tell the last one for the same. I think I got them. Somebody tell me if I have a mistake. Yeah? Liam, you're up front. Looking good?
Yeah.
Yeah? Okay, I have it right. Okay, everybody have data in? We're ready for the next step? Step. Edit.
And then you put in just these numbers and you enter out to the take it off one, and then press the clear button, and then put that to
All right, so we got them in? Okay. This may sound familiar. Press stat. Press calc. Right, we've done this before. Now don't press 1, right? We're used to doing one variable statistics. This process that we're doing of fitting a line to data is called linear regression. Can you find the correct command? Number 4. So press number 4, linreg. Now, look how it says AX plus B. Doesn't that look like MX plus B? That's a line. Yeah, yours is a little different. I'll be right there. If you have an upgraded calculator, it's looking slightly different, you're just going to have to wait. I have an old calculator, you're just going to have to wait. Now, if you used L1 and L2, then you're great. You don't have to do anything. Go ahead and press enter. If you didn't use L1 and L2, you have to enter them. Anybody not use L1 and L2? Okay. Press enter. Y equals AX plus B. Here's A's value. Here's B's value. So we're gonna round this. Let's round to the nearest hundredth. What is this number to the nearest hundredth?
6.1.
To the nearest hundredth?
Oh, 6.1.
No, 63. Okay, I'm looking at A, and I want it to 2 decimal places. 6.09, right? You look one over, the 8 says move it up. What about the B, the y-intercept?
53.93.
Okay, so let's see. Y equals 6.09x plus 63.93. Did we all get this? How many bests can there be? One. Did we all get this? If you didn't get it, look at your data. Because based on this data, this is what you should have gotten. Now, if you have an upgraded calculator, you're going to have to wait. I can't show you how to do it on this board. Just wait a moment. All right. Now, predict the grade. Now, the whole point of doing this is to make predictions. So let's say this was yesterday's class took this, and you have this data. You're like, gee, I only studied 3.5 hours. What am I getting? Right? How can you tell? Now, first of all, look at 3.5 hours. Based on your data, which list would you go with, the X list or the Y list? X, right? It's an X. Isn't it? Hours. Hours is X. So I have an equation here. If I know X, how do I find Y? Plug in X. So Liam, what's this going to look like now? 6.09.
Y equals 6.09 times 3.5 plus 63.9.
Okay. So go ahead, type it in. Somebody type that in for me. Got it right here? Oh, that's what you had. What is it? Type it in, what do you get? What do you get?
I got, 85.25.
85.25. Now, how should I round this? Because am I giving you an 85.25?
Oh.
Oh, no.
That's very round.
85. Does that seem like a reasonable thing to predict based on these other grades?
Yes.
It's not a bad prediction. Does that mean when you take this test, that's what you're getting?
No.
It's a guess, right? It's just a guess. It's saying all things equal. If you study 3.5 hours, statistics say that's what you should get. What if you were studying 3.5 hours with the TV blaring in your head? You might not get it. What if you studied 3.5 hours, but you didn't do a stitch of work the whole rest of the time? Because you get an 85. Probably not. So it's not like magic. This is what you're getting. It's a prediction. What if you want better for 85? Maybe you're going to study a little more. Let's try this. Predict what grade would you get if you studied for 10 hours. So same kind of thing, except now what's x? 10. Okay, somebody calculate this for me. Tell me what you get. Tell me what you get. Not in your head, just put it, type it in what you get. Type it. You guys supposed to be the fast typers.
124.8.
124.83, so like 125?
Yeah.
That reasonable? Well, these are percents, right? Do I give extra credit? No. Yeah, so, well, what happened? This one, I made my prediction, we're like, yeah, that's a pretty good guess. This one's silly. How come?
It's over 100 instead of 10.
You can't get more than 100, so why is my model failing me?
It's over 100. More than 100.
Well, think about the real life situation here. When you get to 100, doesn't this level out? You can study 100 hours, not get more than 100. So is the whole thing really a linear function? Not really, but it's very linear in this interval. So sometimes the models fail us because we're only looking on a certain interval where we know information. Usually or often when you get outside that interval and the farther away you get, the less reliable your values are. Let's look at the second part of this question. How many hours did someone study if they got a 50%? They got 50. So how many hours do we think they studied? Well, we don't have to guess. Well, we have a predictor here, right? Here's my equation. Now, is this 50%? Is that an X or a Y?
That's a Y.
That's a Y, so where does it go?
It goes in the Y.
Here. So let's see, we say I know the Y. Let's find the X. Can we solve this equation? Say yes.
Yes.
How do we solve it?
Subtract.
Subtract 63.93. And then we're going to what? Divide by that 6.09? No, I don't know what that is. I'm not that good. 50 minus 63.93. And then we divide by that coefficient 50.09. Well, that means about negative 2.3. Negative 2.3 what? Hours? Yeah, they studied negative. So what they did earlier was they went home for 2.3 hours and they said, how can I forget this? Like trying to get information out of it. Which, you know what? Given some of the test scores, I don't know if that's happening or not. Maybe it is. But again, is this reasonable? No, right? We're not negative hours. Yes, sir.
10, 0 is at 63 and 50 is less than 63.
Well, yeah, I mean, our model does its best. Well, again, we're looking at my model. So my model goes to 65, but you're right, the actual data, the best we can do is a 63. So anything lower than a 63, we're not going to be able to predict very well. And it could be maybe this class is a little higher than another class where maybe their low grade might have been a 30. They're going to have a different line and different predictions that they might make. So it is all just based on what we know to make predictions we don't know, right? You can't have negative hours. It's not reasonable. So part of this process, can't have negative hours. Part of the process is analyzing what you get. Is it reasonable? Like, yeah, that one kind of is. It's right in the thick of our data. These aren't. They're outside our data, too far away for me to be able to make a good judgment on it. Make sense? Okay? So that's the whole point. And that's what statisticians do and researchers do. Am I happy with this? Am I not happy with this? I want to kind of go through this a little bit more with the calculator. Did you have a question? So it's kind of like, you decide, does this make sense or not? And that is really, to me, anybody can learn how to push a few buttons. But the learning how to analyze the data to me is the important part. What? Don't worry, I'll get to you. Hang on. Just hang on for a moment. Now, if you turn it over, there's a whole big story on your calculator sheet there, the steps. And I want to go a little bit more into another way, a little less a little less writing stuff down. Now, it's not that hard, it only looks hard. This part that I'm going to show you first, only if you want to see the plot on the calculator do you need to do this. So if you look above y equals, do you see where it says stat plot? Everybody see that?
Yeah.
I'm going to press the second button in the y equals for stat plot. These are different plots you can make. Number one says it's off, so press enter, and we're going to turn it on. See how I'm blinking here? Just press enter, it turns it on, and that's all you have to do. See my quit button above mode, so just quit out. Now your plots are on until you either turn them off or you reset the calculator. So if you do a second plus L1, it goes away. So that's the first step. You enter your data, which we've already done. Now we're going to go back into stat calc, and we're going to do our lin reg. Now if you have a fancy new calculator, and you do this, right now, did you see like an L1 and an L2 on your list there? It asks you what list you want. It's already got it on those. First we have to type it in. Second's L1. You need a comma. Everybody listening, you're talking. Look under the 7, above the 7. See the comma? Press it. L2, you type in your list that you're using. And if you have a calculator with menus, you tell you what the list is. I'm going to do this right here. If you have your calculator, Matthew, you see where it says something about store reg or something like that? That's where you're going to do this. So key down to where it says like store reg. You're going to press, everybody listening, watching. Remember bars? Right below the down arrow key. Press bars. Pressing it. Move over 1, 2, Y bars. You don't have to press anything now but enter. I want that first choice, and I want that first choice. Y1. Y1 is located on your graphs. That's Y1. So this is what you should see. Lin reg, L1, L2, Y1. Did anybody get all that in there? If you didn't get it, then just hold on. Press enter. Now, nothing looks different, but what is different? If you want to see your plot, listen carefully. Press the zoom button. See the zoom button up here, the middle button on the top? And then we're going to go to number 9. Zoom stats, statistics. I'm there, I press number 9. If you want to see it and go, wow, that's pretty, that's nice. There it is. Bring your glasses. I keep telling you, it's like the second half of the year. Bring your glasses. Bring them. All right, so hopefully you got to work it on yours. Now, the other thing it did is if you look at, I'll answer questions in a moment. Just look up here. Y equals, if you press Y equals, remember Y equals? Where we type in Y equals X plus 1 or something? Look what you put in Y1. If there's a lot of stuff here, it's your function. It's Y equals 6.9 plus 6. It's your function. It's in there. That's how you know how to graph it. And even cooler. Look at this button here. Where does it say graph? Look above it. See where it says table? See where it says table? Press second in the graph button. It brings up the table. Whoops. So what is this? For x of 0, this is your function's value. For x is 1. So when I wanted x is 10, I could just scroll down for x is 10 and see that this is the value. It doesn't look right. I must have something's messed up. Oh, that's why. Yeah, here it is. Right? Now, all right, now, wait, let me finish talking here. Here's the 50. Let's say you wanted to know what hours were for the 50. That's the Y column. I'm going to look for 50. It looks like I need to scroll up a little bit to find 50. Somewhere in between here, between -2 and -3, wasn't it? This does this for me. This does it for me. Okay, hang on. Now this one, there's more. Who's ready for more? Some of you are like, my head's exploding. Stop. Who's ready for more? Come on.
Wait, not yet. Wait, what did you press after?
What am I going to do about the x is 3.5? Okay, I'm going down. Right, it's a number between 3 and 4, right? I know what that is. It's 85, right? It's somewhere in here. You can actually fix this up a little bit. Just watch. Look up. See my window button? Look above window, you see table set? Press the second button and that window button. This table starts as, when I open my table, where should I be positioned? I'm going to say by 3 because I want to find 3.5. Delta table. Remember a delta? Delta y over delta? A delta is like a change between each step that you're looking at. I'm going to change it to 0.5. Why am I doing that? Each entry now is going to be 1, 1.52. Look what happens to my table now. See, it's incrementing by half. 3.5, 85.23. Now, yes, the first time you look at this, your head is going to explode. After you do this a few times, it's not so bad. One last thing, just one. Because, I don't know if you noticed this part of the question. It says, is it a good fit? Anybody notice that?
Yeah.
Anybody notice that? How do you answer? Well, you're noticing it now. Let's answer that question. How do we do that? If you recall, I hope you do, I talked last time about the correlation coefficient. It looks like I spelled it wrong. Anybody remember the correlation coefficient at all? What that was? Everybody listening to that time? Do you remember what it was? It was no. The correlation coefficient. It's the statistical variable R. It's a number between -1 and 1. If you are a 1, is everybody? You are so not listening. I'm looking around. Nobody's looking up. Everybody's somewhere else. You will not know this unless you look and listen. If you were to graph your data and those points made up a perfect line with a positive slope, you'd be 1. If you were to graph your points and it was a perfect line with a negative slope, it would be -1. If you were to graph your points and you couldn't fit a line at all, no way. 0. You are rarely any of those things. You might be a 0.6. You might be a -0.8. Those are numbers that tell you how good is my fit. How close am I to being linear? So I want to figure that out for this. My line here, is this very linear? Is that good? Now we saw before that correlation coefficient, the R, was a crazy formula. Fortunately, this thing will calculate it for me. Now there is another way to get here. I always forget what it is. So it's through stats somewhere. I'm going to use the catalog. If you look at your 0 case, see catalog? So press the second button and 0. What's nice about this is anytime you forget a command, these are all the commands that the calculator can handle. You need the absolute value, just come here in case you can't remember how to get there. Now the one I want begins with D. So you see this little A here? This means your alpha button is pressed. So look at your alpha button, press it a few times. See how that A goes on and off? See it? Alpha. Yeah. You want the A on. And I'm going to press D because I want this to position it by D, and I'll help you find D. If you count down like 2 from the alpha button, do you see the x to the -1? Look up, it says matrix and it says D. And the D color should match your alpha button. So I want the D because if pressing it will just position me where the D's are. If you can't remember that, you're just going to have to scroll for a while. I'm looking for the command diagnostic on. Looking for diagnostic on. You find it?
Yeah.
Okay, your arrows here. Diagnostic on. All right, press enter. Press enter again. Done. Right? It doesn't do the command until you press enter again. Diagnostic on. What does this do for me? Let me show you. All right, we're going to do the whole command again. Stat, cal. Now listen, if you don't care about the plot, this is all you have to do. Stat cal number 4, L1, L2. Type in your lists. Don't forget this comma, it won't work. All right, bars. Move 1 to the right. Enter, enter, enter. Oh, more stuff. If you didn't quite get it, just look up so I can explain what you would see when you do get it.
Why did you
Right? Look up. If you didn't get it yet, that's fine. Just look up. R squared is another statistical thing. I want to call it the coefficient of determination. I can't remember what it's called. It's another way to show about a good fit. But we're just going to look at R, the correlation coefficient. How close is this number to 1? Very. Like if you were to round this to the nearest hundred, they're at 0.99. So do I have a good fit? Yes. Yes. R is 0.99, which is close to 1. And that's all the stuff that we need to talk about. So let's recap here. If your head's about to explode, stop it, stop it, stop it! All right. You know how to find R. Just go to catalog on, turn diagnostic on. That's all you have to do. Diagnostic on. And do it with just do Linred. Boom. Out this. Plug everything in by hand. You're fine. That's all you have to do. If you like pressing buttons, do the Linred, L1 comma, L2 comma, bars, move over one, under, get the Y1 and keep going. It's interesting, when I show people that I get two responses. One is, wow, that's great, I can't wait to do that. The other response is, wow, that's too much, do I have to do that? Those are the two responses I get. You may know already where you are. I say give it a chance. Because remember, they always look complicated the first time you do them. And then after you do it a couple of times, you're like, okay, I got it. Okay, so I think we've done it.